Hello, everybody. Yep, it's working. I'm going to get started relatively promptly because I've got more that I want to say than I can fit into the time available, and that's even after I've cut lots of stuff out. I'll also say thank you very much for coming to this because I'm certain it's Experience Builder in the room next door, and you're getting a deep dive into dates. So thank you very much for the interest. I'll just reset my timer here so I can check that I'm not going to overrun, but we'll see. So dates. We come across them all the time. You know, it's in core. I don't actually spend too much time about talking about the input formats. I had to cut most of the UI stuff out. We're in the back end, but I will come back to some of the UI stuff. And sometimes it works really well. Deutsche Bahn managed to get the time zone correct and still get the time it takes to get to the UK correct. Sometimes it doesn't. Meetup gets time zones wrong. I'm looking at what's happening in London. It's telling me what time it's happening in Amsterdam. And on repeating events, they actually show it in Eastern Standard Time. I don't think you're going kickboxing at 5 o'clock in the morning. When you click through to it, it remembers it's in London. But, you know, it's not just time zones that matter. Even on your commerce site, you're quite often going to have a date. And this is a Drupal site. And that really is, you know, so it's got a date for when the promotion runs out. You do not want to get that wrong. OK, so they're everywhere. We deal with dates all the time. So in this session, what I'm going to do, it's two halves. I'm going to show those. I'm going to talk about date time in general. I'm going to talk about the standards, how they can be stored, and yes, inevitably, we have to talk about time zones because time zones are just one of those problems. And then in the second half, I'm going to be talking about what we do in Drupal. I'm going to be looking at how we store them, how that has effects on the granularity, dealing with recurrences, the common problems that if you've been doing more complicated things with dates, you'll have come across. So, standards. Compulsory XKCD. You know, you've got one standard, and standards are kind of boring. But I want to argue that, in fact, the people who've been building these standards, and they've been building these standards since 1970, right up until the present day, and I'm going to run through them all, are actually kind of clever people, and they've been dealing with actual problems that we come across every single time. So if you actually, as we run through the standards, you'll see, oh yes, we need to deal with this, we need to deal with this, and so it's kind of a good way of learning what's out there and what we need to deal with. So the first one, I keep on going the wrong way. First one, so the Unix epoch time standard, it's kind of the simple first one. It was devised sometime in the beginning of the 1970s. All the dates I'm showing are the 2nd of January 2025. Not that you can read it because it's in seconds since 1970. Ignoring leap seconds. It gets more complicated if you do GPS because they included a couple of the leap seconds before the standard was made. And it's stored in UTC. It's really, really, really good because maths do integer maths, but computers do integer maths really fast. So it makes complete sense. Interestingly, PHP deals with the leap seconds by having the same second twice. It's quite normal for computers to do this. Apparently, Google's really cool and just slows time down nearer the moment, and you have longer seconds at the end, so they don't log the same second twice. So that's the first one. The next one is kind of probably evolved around the same time, and you'll see the first new thing that comes in. We've got we don't just deal with UTC, we deal with a offset of time zone. It's been made so it's readable. You see it all over the place in headers and so forth, but we've got offsets. Then the next one is the ISO standard, which is the ISO went and tried to fix everything all in one go. It was actually probably started earlier than this, but was made in 1988. It's also not free. You have to buy it, which is probably why no one's ever read it. I've not read it because I haven't got a copy, but I can tell you what the Wikipedia says. what the first thing you'll notice, the next problem that they're solving is granularity. You can say how accurate the time is. So now it's down to the hour or the day. The Z that's being introduced there is a standard form for UTC. They also went and worked out how to do a duration, which is the top one. You do see that used quite a lot. So it's like period, 3 years, 6 months, so forth. It also has ranges, start, end time, or start and period. And it also starts to doing repeating dates. I have never seen anyone use the ISO format for repeating dates, ever. Maybe it is used somewhere. But we'll come to the standard that people do use for that one. But these are more problems and more ways of solving them that already exist and that are out there. So then we had this RFC, which realistically, it's just a handy way of the bit of ISO that everyone actually uses. The one problem that it adds, that solves, that the ISO standard didn't do, is dealing with UTC when there is no local time. Most things are actually happening in a local time somewhere, and you know what the time zone is, and that's where it's actually happening. It introduced the idea of, actually, I don't know what the local time is, it's just UTC. And this is something that you occasionally need to know. But generally, it's just better because it's not got everything and all the variations that the ISO standard still has. And then repeating dates. Like I say, we'll come on to them even further when we're talking about Drupal. I should mention, yes, this is also the first time you notice that not just the offset of the time zone is mentioned, but actually the time zone name. So Europe, London is used, or whatever. I'll talk about that in a moment. It also introduces this repeat rule, so that's how, not the ISO standard, that's how most people deal with describing, and it's super flexible, you can describe all sorts of things, where it starts, what the repeat rule of a date is. It also, and this quite often gets forgotten, explains a way of overriding any one of those instances and how to say that this one was scheduled to be then, but it is now then. So there's a standard for that. And there's a QR code at the end, which will link to these slides, and then you can click on the link in the slide, where you can watch me watching Google's iCal feed, where I add an event, make it repeat, then override it, then change the order of the original repeat rule, so the override no longer makes any sense. And then I change it again so that it kind of does make sense, and the override reappears. So I think underneath, Google are actually using this recurrence reference and sequence to deal with their the repeat rules. So, clever people also reuse the standards and kind of go, yeah, we can do that. And then on to the last one. And you will come across this one in the future. What's new here is we have offset and named time zone. We actually have even more. We have what calendaring system it's using. So now you can specify the preferred calendaring system for the date, and then you can add anything. They've made it extensible. You can add anything. As long as the sender and receiver have agreed the key value, you can use it. Why you're going to come across it more is because, unlike PHP, which had Derek Renthans, pronounce his name, who overhauled the date time system and thankfully fixed loads of the time zone problems, made us date immutable, which is lovely. JavaScript didn't have an override, fix of their date time system for yonks. They have now. It's called the temporal API, and it serializes and deserializes to this. And yeah, that's the 2024 standard. So this is the last one, and you can see the new things that we're having to fix and deal with. So after all that stuff about Standards. What about storage? Standards. No. The thing that all databases and object storage seem to agree about is you can store integers and you can store strings, so you can put the date in a string. After that, they do not agree. They all have different native forms of storage. I really want to try out this solar date range field. Like, I did the research for this. I've not had time to try it. But doing stuff with date ranges can be a complete pain. They've got native, like, does it intersect? Is it contained in? And stuff like that. But yeah, depending on what backend you've got, and if you've got SQLite, the advice is just use text or a float, or use an integer, so timestamp. Thank you. So maybe standards are good sometimes. So back to standards, and time zones are standards, and they were fixing a problem, or they are fixing a problem. The very small picture you can see, it's not too bad, is the original station in Leuven, which was built. The train arrived in 1837. And by 1840, Belgium had already fixed on Brussels time. So we couldn't have these trains moving around, people moving around, factories even working on a different time zone to the city centre and stuff like that. We standardized things. That's where the standard came from. After that little story, the ones that we actually come across and we should understand and be dealing with are the time zone identifiers, which are controlled by the Internet Assigned Numbers Authority. And why they're kind of important is they're better than those GMT three-letter things because, well, sometimes the abbreviation means different things. And also, they've made it so that it covers an area and the time offset can be different within the time zone. In fact, they've gone further. I'm not going to read this out, but the point, if you can read, you can look at it afterwards. The point of it is they've tried to make it so robust that as there are political changes or, boundaries change or they change the time zone, it should still reliably have the same area name. So they've solved that problem. Now, little anecdote. This gives you some idea of how it works. You can see China. So this is the time zone offset to what it should be by sun. And you can see China with its, Beijing time across the huge area. But the reason I show this is not only because it's quite a nice map, is also because the person who made this, a few months later, had to remake it. And it's not just because they realized that red-green is a really bad thing to do, so they changed it to blue-red. But actually, the whole of Russia changed its time zones, so the offsets are all different. So they had to remake the map. And in reality, the time zones do actually change quite a lot. If you look at the slides, there's a link on the bottom for the person who very kindly made this table, particularly because it's kosherjava.com, so sometimes the specific times of changes can be more important for religious reasons, for example. But yeah, so that's why they made that list. And the changes, all those changes, can even happen retrospectively. This is Lebanon 2 years ago, and they couldn't decide when they'd started observing summertime because of Ramadan. And so it was like a couple of weeks later they specified how it had already changed. Why this matters to you is because these changes get into your database, get into your website, and will affect what you read as UTC time. And it's just almost interesting to know how this happens. But so there's an email list, like proper old school email list. I'm going to try and describe what happened on this particular thread for Kazakhstan in 2024. Someone sent in an email saying the government has announced they're not going to deal with summertime. Somebody sent in a patch. Somebody sent in more evidence that was actually not just the news article, but some official document. The maintainer, who's Paul Eggert, who seems to be like the benevolent dictator for this kind of thing, who merges all the requests, accepted it. But then someone came along and made some nitpicks about some of the specific details on it. So another patch went in. It then went into the change log. And then finally, it goes into the next release of the database. And then how do you get those? Well, in PHP, with each release, it packages up that database. And you can ask, and it will tell you what version of the database you've got. So you've got a reasonable idea of what you're converting, unless you use Debian. Debian asks the operating system for it. So they get database updates more often. So if you're running a Debian system, your time zone database will be the same as the operating system one. Or you can install the PECL package, which will update the time zone database yourself more directly in PHP. Again, maintained by Derek Rethens. So this is where UTC storage gets a little bit difficult. If you've got a date in your database for something that's happening in a few days' time in Paraguay, you'll have stored 4 o'clock. You'll have stored it. If you stored it before the 16th of January, you know you stored it in UTC -4, but you know that it's actually UTC -3, so you need to correct that date that you stored because it's wrong, because it's been changed. But the change was only went into the database on the 16th of January. Now, if it was stored after the 16th of January, which database did you have? The old one or the one they just released? I don't know. So, do you correct that to be happening? Is it happening at 5 o'clock, or because it was stored then, or was it, should it be stored as 12 or 13? I don't know. So yes, we don't know which database we're using necessarily, and they change. So that's a problem that, happens in some parts of the world more often, but, they're promising one day, it's not going to happen, but they're promising one day to change it in Europe. Anyway, so I'm about on time, which is good, and we've got up to Drupal. So, within Drupal, what do we do? So I'm going to briefly mention core, look at some of the modules that we're using, and then see how we store stuff and how that affects what we do with granularity, and also then, because recurrences are such a thing, I'll do recurrences as a whole separate section. So I haven't mentioned it because it's not a module, but in core, of course, you've got the created date and the updated date, changed date, sorry, and they're stored as timestamps using the type data standard. Then we've got core modules, datetime range, which extends it, and then we've got recurring dates field that extends that, and then we've got smart date, which I suspect most people might be using, which goes back to the timestamp. Well, we'll look at it in a moment. I'll also mention other modules that can help or do other things, including definitely Search API, because I'm sure lots of you have got Search API, and it stores things differently again. So it has a big impact on that. So what do we actually store? Now, this is easy because we've just been through the standards, so you'll recognize all of this. With the core date date only, so this is when you say it can only have a day, you can see granularity, and it's stored in UTC, but we don't know what the time zone is. Actually, for days, that can be quite useful because it's just happening on that day, and that's what we want to know. But also the same thing with the date time. It's just in UTC, we don't know. And then the range is the same, except it's got a start and end date. Then recurring dates field extends it further, but it does add the name time zone, so we know what time zone it's happening in, and all of a sudden, yep. And then it includes those iCalendar repeat rules. And then smart date is storing the UTC Unix timestamp. It does store the time zone. It should be there, but it can be optional, so you don't have to input it. And then it has a reference to the repeat rule, which I will talk about when we get onto the repeating dates. So, did I say? I think I overlooked to say, so the first ones, or all those that are inheriting, are storing that thing as a string in the database, and this is getting stored as an integer, or the equivalent thereof. So this has been a thing, like how do we deal with this and how do we store it? For a long time, this is off groups.drupal.org. It's a conversation that has, how do people look? Earl Miles, the Merlin of Chaos on it, and Robert Douglas here, who's saying what the patch that Karen Stevenson, who was doing lots of date stuff back then, had come up with. And she had come up with a thing for the date module back then that allowed you to store a timestamp, a string, or a native MySQL datetime field. And it caused lots of confusion, I know, including to myself. Which one should I be storing? I don't know. But it was, really useful that you could actually choose between all the different things. And it also let you choose what time zone it was being stored in. You could even store local time. But you only did one or the other, and people definitely got confused. But we were able to do that in Drupal 6, Drupal 7. The other reason the thread is interesting, because there was this long debate about, does it matter, should we be trying to get date time storage in? Should we use a string? Should we use an integer? And the consensus on the thread is that the native database storage would be best. If that's not available, we should do an integer. And if that's not available, string. So what core did by storing a string was completely, not what was on this thread. But there's no evidence on the thread. It's just, gut feeling. And so I'm the kind of person who sometimes goes, I'm going to do a presentation about this. Let's find out. So I did. I generated 1 million nodes for the core date range and 1 million nodes for smart date. And then as an experiment, I cloned the schema from the core date range in MySQL, but turned the string into a date time, and then just copied all the values across so that we'd actually have the same thing in core date time. The numbers on this are the numbers of seconds. I have rerun these queries over and over again. Some of them I do not understand why, like how it could. I'm going to talk through my best guesses. But again, the original queries, results, and the explain describe. So if anyone's like really into MySQL or SQL and can look at it and work out what is happening with the indexes and the stuff, that's something to do tomorrow, isn't it? And let us know why. Anyway, but by and large, the idea that you don't store things as strings and have to convert them into dates is true, but not. It's 1 million nodes. It might not be that important to almost everyone. But some people who have sites that have quite a lot of dates in them, it might start to become more important. But yeah, and then having the integer is definitely more often, better, and is common across all systems. But just looking at some of those examples, so this is one where, yes, it's slightly slower, but it's actually surprisingly slow, just across all of them, just to list them in order to get the top at the 10 out of the thing. I assume it's all the same, because you've got an index on a string, and you've got an index on an integer, and you're just getting them all in order out of the index, and the string is actually in order. So I suspect that's why they're quite similar. Between two dates, this is where we start to see this really horrible thing that happens. So it stored the date as a string in UTC, so it then has to correct it, but it shouldn't have to correct it because it knows what the date is. So why views makes this thing, I don't know. And I've got this is the one of the odd outliers, because the core date one, which has that horrible query, works out quicker than smart date, and I've no idea why. But one of the theories that I've got about this is that, well, I assume SQL optimizes all this rubbish out because it's completely unnecessary, works out what the string is for the start date, works out what the string for the end date is, and then goes to the index and give me all the things in between the two. Why it would be so different, I don't know, but I assume that's what's happening. But and then this is one, this is where even if you stored it as an integer, you're going to end up converting it into a string. If you want to group things by day, which is, I don't know, I do it all the time. I want to get, everything that's happening on a particular day out. You end up having to convert the integer to a string in the day, and it seems like MySQL, this is a DDev container with actually MariaDB. I haven't done anything with it, and it seems pretty quick, actually, for doing it. But yeah, it's converting it into strings so you can then filter on the day that it's converted to after you've done the time zone correction. So, so if you're building a site and you don't need to, it might well be worth avoiding doing that conversion to string time zone correction, and if you can just sort by second, it's going to be better. But if you do need to do things by day, and you might want to filter by day, we get into what is called granularity, or in the standards, they call it reduced accuracy, which is also, because you don't know how accurate the time is. So, this is my filtering example. You want to filter stuff by day. Now, again, examples I actually have. I want to know everything that's happening on May Day. I do want to show stuff in relation to when it's happening from now to people in different locations, but I also need to work out whether it's happening on May Day. But May Day could be in anything of, what is it, almost 48 hours across the world. So you'd have to query everything in that period, and then work out if it's in the time zone that means it is that day. I don't know. My solution to this is I know I'm going to have to do this, so I'll use Search API. I use Search API for all these sorts of things. If I've got a complicated calculation to do that I can store beforehand, that's what I'm going to do. And then I can do a really simple query. So I can just store local time, the day, and I can also use that for grouping by month or whatever. But if I knew I was only going to do month, I could do that. And I do it, I don't know if other people do this, but it's also really, there's aggregation fields and things like that. So you can actually, if you know how you're going to use the data, rather than doing complicated things, storing them on the entity, you can just store it in this disposable piece of information that you put into your search index, and then use it on your view on the way out. I do have to say there is no token for displaying things in local time. I should probably, but I made one. so I should probably release the code or do something that, would make it useful to, say, I want to show this in the local time of the event, or I want to show it in this particular time zone, or I want to show it in the user's time zone, or whatever, which is you have with everything else, but you don't have with tokens. But that works, and I'll make the code available if anyone wants it. But this is where I do kind of appeal thing. It would be really nice if we could store what the user entered, which is really robust, in the time zone they entered it, and then calculate the time for doing the more complicated things where we want a calculation. It would be really nice. We could even make it pluggable, and then you could swap out the time zone and swap in the database one that actually works with the database that you happen to have. And then you could use the probably most efficient. This isn't completely abstract. I've been playing around with doing it because I have this, mainly because I have this itch that I need the local time as well. It would also solve that time zone recalculation problem if we stored what people actually entered, so it would be a bit more robust. And we can also store exactly the granularity they entered it in, so we don't need to work out additional ways of working out whether it's exact to the month or the year or whatever, because we'd have stored it and we could just look at what they entered. But then still calculate out. It's an option. The trouble with fields is you have to inherit, and it's really hard to add or change the field. If anyone's looked at GeoField, however, and I suspect no one, because hardly anyone uses Postgres, but it actually has a plugin, and you can swap the storage to use the native Postgres storage. You could also do it for there is now native MySQL Geo storage, but making queries on it because of the SQL abstraction thing that we have, and the way they've made the queries in MySQL doesn't play. It's horrible, and I haven't worked out a way around it. It is a core issue somewhere. Anyway, complete aside. So seconds, less important granularity, but I'm just going to mention it very quickly. You can just hide them in Smart Date, and if you're not using Smart Date, there's a module for that. Get rid of them. And if you're using something completely different, just copy and paste the code out of this module and stick it in. Problem solved. So we're on to the last bit, and we're on to recurrences and recurring rules. And I'm going to come back to that search API thing again, aren't I? So this is a real example. It's a real event. So every time I've ever rolled out a site, we have a discussion about the best. I said I'm not going to do too much about UIs, but the best way of inputting recurring dates. And you want to make the UI as simple as possible. And with date recur field, there's 4 pluggable different versions that you can use. And we try and start with the simplest one. And every time we end up with the most complicated one because people want to enter complicated repeat rules. It just always happens. So this is an event that does happen monthly on the 3rd Sunday, and if there is a 5th Sunday, it will happen on the 5th Sunday. You can put the same thing into Smart Date in much the same way, and it has the same flexibility on choosing all the things. It's just a shame that you can't put it, because it is in fact just one recur rule. You can write it in one recur rule if you can write recur rules. But I can tell you, not even Google lets you do that because they want to keep the UI simple. So you can only do the 3rd Sunday. You just have to put 2 events in, And then, of course, we have the problem that then it's not happening on Easter Sunday. It's the 3rd Sunday, but it's not happening. This is date recur, or recurring dates field, as it should be called. And this is Smart Date, which lets you say it's not happening, or it lets you make an override, which then says, no, it's just happening 2 hours earlier on this particular day. So that would be the recur rule for it all in one. So the standard does have a way of representing it, and there are PHP libraries out there that can create and write them but UI challenge for anyone out there to manage to make it easy to write that rule. So storage, how's this working in Drupal? This is interesting, both just because of what's the most efficient, what's the best way of doing it, but also how does it interact with Search API. So the recurring date field stores the recurring rule on the field itself. There you can go, you see it twice. And then it has a completely separate table, which is not like a Drupal table. It just announces the schema, and then it puts the instances in that. Now, this has its bonuses because it's really light. It's almost like a cache table. You can just whap things out, throw things in. You can recalculate them. It's really quick. I will say, however, that it has entity ID and revision ID there. It only stores the one from the most recent revision. There is a patch to fix that because, of course, sometimes the published revision isn't the most recent revision. And it has no history of changes or anything like that. So with revisions, bad. But you know, it's a good, quick way of doing things, and it makes this kind of scratch table that you can still do joins on, which we'll talk about in a moment. Smart Date does it the other way, and it goes the Drupal way and makes deltas for every single one of the instances. So it's as if you'd entered them into a field loads and loads and loads after each other, basically. This does have the opposite thing when you're doing revisions. It works really well with revisions, but it means it saves all of those for every single one of the revisions. So for the repeat rule itself, it has a separate entity, which you saw was referenced, and in there, it then has the repeat rule for that date. And I got quite excited about it because I worked out, hold on a second, we've got this sequence thing, and with the iCal standard, which means if we stored revisions of this, then we can know which sequence ID it is for that particular revision. So it might be useful, that. And then the overrides themselves, because of course you can, here this one was removing it, but that's where you can then store the different start dates and end dates, which is also starting to look like that iCal rule where you have the instance again referencing the override. But anyway, so listing. So as I mentioned, you've got this separate table, or the thing, it means you do different things. So in views, if you're doing date recur, you actively have to join onto that table. You have to add a left join, and then you can use the fields, and you'll have them. And that's it, just joining on the table. And then having those horrible views queries that you get with the string. With Smart Date, you don't have to actively do the join because you add the field, and of course, it's automatically joined on the field that's storing all the occurrences. And if you uncheck this on the display settings, it doesn't put all of the field together in one. It shows each one of the rows. But behind the scenes, there's a left join. It's just been made for you because that's what Drupal does. That's how it deals with the tables. These I don't need to mention because you saw it this morning. Most of this stuff you don't need to build anymore because they're in recipes. But what happens when you get to Search API? So you can use Search API. This is me putting Smart Date into Search API. It works. I put the thing in, and I get one row for each entity out, and it's stored all the fields underneath it. To get this nice, neat output of it, I still have to load the entity, because otherwise I've just got all the dates on one field, and it's just like, boom. So it's not ideal, and you definitely can't do multiple rows for each one of them because we don't have that join anymore. We're in the world of just storing individual entities with all the data on them. In recurring dates field, I've actually solved this before, but Joachim has very nicely actually made a proper stable module out of this. And what it does is this is not a Drupal content entity. This is a search API content entity. It's the item it puts into the database. And it generates one for every one of the instances. And he's made it nice because you wouldn't know that's happening. It all happens behind the scenes. It looks like you're just entering the one date. And you can choose the fields off the date, including the occurrence itself. And it puts it into Search API as lots of different occurrences. And I noticed, just in writing this talk, and I've not had time to look into it, that somebody's done the same thing for Smart Date. I have not tried it, but it would be very interesting because if you can override the date, that means you can store the instance with the correct overrided date. So you actually have like an entity, but a disposable search API entity with the correct date for the different instances on it. Which brings us on to the last thing I want to talk about. I hope you're still there. Is what do we do with all these different instances? And it gets complicated, particularly when you want to override them. So what you commonly want to do is actually enter a repeating sequence and then update it to say, but the description for this particular instance is this, or whatever. And as we saw with the iCal standard, calendar standard, that works quite well. And that Google instance of it having an overridden version that kind of disappears, orphans, comes back again. And I know Martin's tried to fix this. And there's lots of really nice augmenters for the date fields that you can like add calendar and stuff like that. This one, however, and it's me that wrote the issue, it uses the deltas rather than the times. So if you change the sequence or recalculate it, the deltas change, so the overrides get lost. So that needs fixing. But I think with the additional Search API thing, it could work nicely. But if at the moment, if you want to do it, well, you can use some really experimental stuff that I've played around with, but the thing that actually works reliably is you need to have still an entity for every one of the recurrences. There should be better ways of doing it. So there is a module called Recurring Events module, which does create separate entities. Before Drupal 8, there was a Drupal 6, 7 module that literally cloned the entity, the node, for every single one of the recurrences. You can imagine, if I say that, it could be an issue, regenerating the sequences and having a scratch table is a good idea. Yeah, now update that sequence. It's a batch job, it's crazy. So they've kind of worked around it by making a shared field value so that you can actually have a parent value for the field. But it's because at the moment, unless we start to do other things, we kind of have to have an entity ID that's fixed that you can clip onto. But I think there are probably other ways that we could fix this problem. Okay, so that was. Well, that's not everything I wanted to say. I want to say way more than that. But for today, that's probably enough. So hopefully what you've got from this is there are all these different standards, and the people have actually solved lots of these problems. We could reuse some of the standards more within our thing. There is a new standard. It's on the way. If you're doing JavaScript, you're going to be using it. Saving things in UTC is very good. It's great for calculations, but it's not always going to be the answer. Database storage, even the speed of the queries isn't obvious. And, if you're building a site, if you're building views, it does help to have some idea of what's going on behind because, you might actually catch yourself out a little bit. If you can plan for how your dates are going to be used, you can do stuff like I've done with Search API. And handling occurrences and repeating rules is still something we could get a little bit better at. Okay, so I've been ekes. That's where you can find me, and that's where you can find the slides with all the links. It's all in a GitLab repo. So like all the notes I made and all the additional bits and stuff that I threw out, it's all in that same Git repo. And I have finished within time, so there are a few minutes for questions or comments or anything, if people have thoughts. Oh, there's a surprise. I don't know if it needs switching on. It's on the bottom. I think the tech support's coming. Oh, my glasses aren't that good. Is that
it? So first off, I just want to say this awesome presentation. I love like the research that you did, actually comparing the data, speed, all of that stuff. I think it's amazing. I had wanted to do that for years, and then I ultimately just never got around to it. So I love that you've gone ahead and done that. A couple of things I wanted to comment on. Recurring events is a great module. In fact, I did some testing. If you like the Smart Date widgets, they'll actually work with the instance management with recurring dates, so you can actually use them together if you like some of the UI elements or whatever. One thing to be aware of is that it's not a field that you can add to any kind of arbitrary entity. The recurring dates uses a specific entity type, and so that's like a thing to be aware of. The other thing that I wanted to mention, you talked about the overrides in Smart Date. One of the data fields in there is an entity ID. So theoretically, I built it with the idea that like you could override an instance and make that a like freestanding entity if you wanted to like change the title and like do all kinds of other things. So like there's the infrastructure to do something more ambitious there. Nobody has ever asked for it, and so it kind of like people have been happy with it the way it is, but patches are very much welcome.
Yeah, the main thing for me is to fix is what happens when the recurrence changes. Oh. Dunk. There we go. There you go.
Hello. Yeah. Really great session. So my question is regarding the recurring dates. So there is something like rule. Let's say we have a rule like every Monday. So, but the search and everything that we do in Drupal would be based on the actual instances created, if I understand correctly, and not on the rule. Saying, like, let's say, for example, I don't know how many instances Drupal creates if you say a recurring rule.
Yeah, so I just skipped over. On most of them, on all of them, and on that search API module, you can basically say how far into the future to do the to generate the instances. And Smart Date for within the database also has, if I remember correctly, a cron job and a queue to do a recalculation. So if you say, please keep these things in 2 years in advance, it will update it and keep it 2 years in advance, I think. I can correct it, yeah.
Yeah, that answers it. Thank you.
Oh, one up there, yep. Way. There you go.
Yeah, first of all, thanks for your great presentation. I've tried to download your presentation material, and there's a HTTP 404 page. So can you check the slide material online?
It should be the ekes.gitlab.io/2025 date.
Yes, yeah. we tried it.
Okay, I'll have another look. If not, go to gitlab.com/ekes, and you've got all my repos, and it's one of them.
gitlab.com, ekes, yeah. Okay.
Yep, and I'll put it on the session description as well. I'll put a link on there after this. Okay, I suspect we're on time. So, thank you very much.